Yes, dear students, today we will solve the exercise 7.4 of the NCERT that is also on the integration of class 12th. Now, before we start doing the exercise 7.4, we have to learn, or you can say understand, some of the formulae. 9 important formulae are there which I am going to write down on the board. So first of all, you note down these formulae and they are very important. Then you can do the whole of the exercise. We can solve it very easily and it will be that is easy to understand then. The first one is the first formula is 1 upon x square minus a square and integration respect to dx, and the second one is 1 upon a square minus x square dx. What we observe? We observe that 1 upon x square minus a square, in the denominator there are two terms separated by the negative sign, yani difference of two terms, that is the difference of the square of the two terms. Basically, difference of the square of two terms whenever we get, and first one is variable and the second one is a constant, and here reverse is there, the constant is first a square and the variable minus x square, and their integration would be, write it down, their integration would be 1 upon 2a into log of x minus a divided by x plus a mod of this plus c, and similarly 1 upon a square minus x square would be 1 upon 2a and log of a plus x divided by a minus x plus constant of integration, that is c. So these are the straight way we can apply the formula. And whenever we get a question that is the difference of the square of the two terms, we can write down their integration straight way. Now I give one of the illustration to you, and you see illustration is our, suppose somebody ask you integrate x square minus 5 square dx. So clearly it is similar to the first formula, that is 1 upon x square minus 5. Accordingly 1 upon 2a, so a here is 5 because this 5 square, so a is 5, 2 into 5 log of x minus a, that is x minus 5 divided by x plus 5 plus c. So this is the answer for this one. So this is how I think you would have understood the formulas, how to apply it. The difference of the two terms, square of the two terms must have been given. The 1 upon 2a 2 into 5 can be written as 10. So final answer is 1 by 10 log x minus 5 divided by x plus 5. Similarly, in case the 5 is on this side, 5 square minus x square, the second formula we can apply, 5 plus x, 5 minus x plus c. So now let us move to the third formula, that is your third and fourth, fifth formula. What are those? Write it down. After writing these two, the third one is our, that is integration of 1 upon x square plus a square dx, and its integration would be 1 upon a into tan inverse your x by a plus c. So now the answer is, whenever we get the sum of the squares of the two terms, sum of the, not difference, sum of the squares of the two terms in the denominator, their integration would be 1 by a, constant terms a, tan inverse variable x upon constant plus c. I give you the one of the illustration for this one also. Suppose you get the question integrate 1 upon x square plus 9 dx. So now to integrate it, 9 can be written as 3 ka square because we want both to be in square. 3 square. The answer would be 1 by a. 1 by a means 1 by 3 into tan inverse x divided by 3 plus c. So that is what is called the integration of this one. That is the sum of the squares of the two terms. Now let us move to the fourth question. What is the fourth question for integration whenever you come across? That is your 1 upon, now we get question number, formula 4, integration of 1 upon x square minus a square under the root. And the fifth one is 1 upon a square minus x square under the root. And the sixth one is your, that is 1 upon x square plus a square under the root. And our first formula was x square minus a square without root. Now we have given the square root to that. And the second was a square minus x square 1 upon a square. Now we have given the square root to that. And the third one was 1 upon x square plus a square. Now the sixth one comes to be with the square root of the x square plus a square. Now what are the answers for those? The first one is your 1 upon x square minus a square, and that is equal to, whenever you get a difference of the x square minus a square and with the root over this one, that would be equal to log of x plus x square minus a square and plus c. And whenever we come across a square minus x square, that is equal to sine inverse x by a plus c. And this one, third one, that is again log of x plus x square plus a square under the root plus c. So in this way, these three types we have covered. 3 earlier I told you. Now the sixth formula I have written over here. So now before starting the exercise 7.4, these 6 formulae are very, very important one. So let us see. Now after knowing these 6 formulae, we can solve any of the question of 7.4. So let us come to the first question of exercise 7.4 of the NCERT, and that is equal to, first question, just see, it is 3x square integration of 3x square. Question first, integration of 3x square divided by 1 x6 plus 1 x to power 6 plus 1 dx. We have done 6 formulae, and none of the formula straightway seems to be what is called analogous to this one. Doesn't seem to be. We can apply straightway. So why I convert this question according to our formula? So what I do, I am taking x cube is equal to t. When I take an x cube equal to t, that gives us 3x square dx is equal to dt. 3x square. So here the question may already 3 we have. So that is 3x square dx dt. So it gets converted into x cube t. So that means 1 upon x square plus 1 into dt. So what I have done, 3x square dx written as dt. x6 can be written as x cube ka whole square. When x cube is equal to t hai, so that implies x cube ka square is equal to t square. So that is your x की power 6 is equal to t square. So this is what I have written. For x to power 6, I have written t square plus 1 respect to dt. Now, we have done the third formula, that is t square, or 1 can be written as 1 square. So we can straightway apply the formula 1 upon a is 1. So that is tan inverse t upon 1 plus c. T upon 1 doesn't matter, straightway we can add on the t. Now writing back the value of the t, so we get the answer here, that is tan inverse x cube plus c. So this is the answer for we are getting tan inverse x cube plus c. So this is the answer for the question number 1. So what we have done, just listen again. The question was this much. We just reduced, simplified to our form, the formula which we had done, the 6 formula, and this is one of the third formula that is similar to third. I have converted this question and now then applied it and we got the answer. Let us go for the question number 3. The next important question is question number 3 of the exercise 7.4. Question number 3. So what the question 3 says, it says integrate 1 upon 2 minus x whole square plus 1 and with the under the root and our dx. Now if I look at this question, so what I observe, it is similar to what we have done out of the 6 formulae. What we have done, one of them was 1 upon x square plus a square under the root integration, and its answer was log of x plus quotient itself, that is x square plus c. So according to this one, the answer for this would be written as, what would be the answer? That is log of x. In place of the x, we have got 2 minus x plus the quotient itself, that is 2 minus x whole square plus 1 under root and plus c. So this is the answer for the question number 2. Question number 2, we get the answer for this one is your, that is x minus log of x minus 2 minus x and plus 2 minus x ka whole square. Or because it is a square, we can convert here into like this way also, if you want to make it still simplify, 1 upon x minus 2 whole square plus 1 under the root. So we may convert the question like this way, because when we have got any of the number below the square, if we change the negative sign, doesn't make any difference. That means taking out the negative sign out of this one, that become positive. So their sign get interchanged, x minus 2 ka whole square. And then our answer would be here, that is x minus 2, and here 2 we can write down x minus 2 whole square. So it will be, I think, simple for you and quite, because we get the x minus 2 and plus x minus 2. So we have converted 2 minus x minus 2 ka whole square because square was there, so it doesn't make any of the difference. So now let us go to the next important question, that is question number 6 of exercise 7.4. So question number 6, what it says, we have to integrate, write down, question number 6, integration of x square divided by 1 minus x6 dx. So now again, to convert into the form of our formula. One of the we have 6 formulae with us. To change the question to one of that formula, so what we'll do, we'll take up the x cube is equal to t. So that gives us 3x square dx is equal to dt, or x square dx is equal to 1 by 3 dt. So x square dx 1 by 3 dt, x cube t, squaring both sides. In case we square both sides, so what do we get? X to power 6 is equal to t square. x6 t square. So for x6 I can put up t square. Now the question becomes x square dx 1 by 3 dt. 1 by 3 we write down outside, and dt 1 minus t square. So this is how the question reduces to. This our I become now 1 by 3 integration of 1 upon 1 minus t square. So 1 can be written as 1 square. It becomes a square minus t square. Our second formula says whenever we have got 1 upon a square minus x square, the answer would be log of a here 1 minus t upon 1 plus t plus c. So this is what is the answer we have. Now writing back the value of the t, the final answer would be 1 upon 3 log of mod of 1 minus x cube and 1 plus x cube plus c. So this is the final answer for the question number 6 of exercise 7.4 of the NCERT. Now let us go to the next important question number 9. So what the question number 9 says, that is the integration of, it contains the terms of the trigonometric functions, and that is your secant square x. Question 9, integration of secant square x divided by 1 plus our secant divided by under root of tan square x, under root of tan square x plus 4 respect to dx, variable dx. Now very much clear, in case this is secant square x dx, I take up tan x is equal to t. So what the question becomes, it will take the one of the form of our formulae out of 6 formula what you have done today. So one of the formula can be applied. Then let us tan x is equal to t. That implies secant square x dx is equal to dt. Secant square x dx dt, and 1 upon t square for tan square x, t square for 4 I write down 2 square. Now it becomes exactly the form of our one of the formula. कौन सा formula हमारा, what is that? Is integration of under root x square plus a square, and that is equal to log of t plus t square plus 4 under the root and plus c. Now writing back the value of the t, तो we will be getting, हमें क्या value मिलेगी? That is log of tangent x plus tan square x plus 4 under root plus c. So this is the final answer of our question, that is I comes to be integration of this one secant square x tan square x plus 4 dx log tan x plus tan square x plus 4 plus c. That is the next important question of exercise 7.4 is question number 10, and that is equal to integration of 1 upon, that is your x square plus 2x plus 2 under the root respect to dx. So this is our question now. Now you see, what we have done, the 6 formulae, according to those, we want to make it one of the perfect 2 squares we require. It is a quadratic x square plus 2x plus 2, and we want to make it the 2 perfect square. So what is the way how we should do it? I tell you, this is square 2x. So first of all, write down x square as it is, 2x as it is, plus, look at the coefficient of x, that is 2, make it half. कोफिशिएंट ऑफ x का हाफ कीजिए, 2 का हाफ 1, और 1 का स्क्वायर लिख दीजिए. नाउ इट बिकम्स a square plus b square plus 2ab perfect square. Now you see, 1 we have written and 1 we should subtract. So from 2 we subtract 1, again 1 is left. So it becomes like this way. That is your integration of x plus 1 ka whole square plus 1 square under root and dx. So what you have done, whenever any quadratics in the denominator comes up, without root or with root, just make the 2 squares perfect squares, and now we can apply the out of 6 formula, one of the formula will be applicable to that. Now it is, which formula is applicable? X square plus a square, and that is equal to, answer would be straightway, that would be log of your x is here x plus 1 and plus the quotient itself, and the quotient itself is x square plus 2x plus 2 under the root plus c. So this is the answer for this one. What I have written here, x square 2x plus 2 and not x plus 1 ka whole square plus 1 square. In case we simplify it, we get back this one. That is why I have written the after simplified form, and we started from x square plus 2x plus 2 and I just written it back the same way. So this is the answer for question number 10. So now let us move to the next important question of exercise our 7.4, and that is question number, write it down, question number 16. So what the question number 16 says, write down, question number 16, integration of 4x plus 1 divided by 2x square plus x, 2x square plus x minus 3 under root and with respect to dx. 2x square plus x minus 3, this one. Now in such type of questions, when there is a linear factor in the numerator must have a linear factor and denominator may have a quadratic. And the exponent of the denominator must be higher than the exponent of the numerator. So then what we do? We convert the numerator into the derivative of the denominator. And what is the procedure? What is the method for doing so? Write down. That is 4x plus 1. We want to convert our 4x plus 1, that is a numerator, into the derivative of denominator. So what is the way to do so? A times ddx of denominator, that is 2x square x minus 3 plus say b. Now ddx, derivative of 2x square, derivative of 2x square plus x minus 3 into a and plus b. Now we are supposed to find the value of a and b. So how will you find it out? A, derivative would be 4x plus 1. 2x का derivative 4x, x का 1, 3 का 0, plus b. And on the left side, it is a linear factor, 4x plus 1. Now, you see, let us finding the value of a and b by comparing the coefficients on both the sides. That is your 4a x plus a plus b. How I have got it? I just clear this bracket. A multiplied with the 4ax, a multiplied with the 1a and plus b. On this side, we have got 4x plus 1. If I compare the coefficients of x, both sides, so I obtain 4a is equal to 4 or a is equal to 1. And secondly, constant terms, if I compare, constant terms mein here is a plus b and here is constant term 1. So that implies a plus b is equal to 1. A is already 1. A we have got already 1. So b would be 1 minus 1, 0. So value of the b comes to be 0. Now, what we are able to do? We have done the linear factor 4x plus 1. The linear factor 4x plus 1 has been converted into the derivative of the denominator. Or luckily it was already the denominator, but still the values for a and b we have got. A is 1 and b is 0. That is 4x plus 1 can be written as. Now that is equal to, for a write down 1, so we get 4x plus 1 plus 0. Now this value will be substituted for this one. Okay. After doing so, the next step is your, after this you got for 4x plus 1, it is the derivative of this one. So simply take up 2x square plus x minus 3 is equal to t. And we get 4x plus 1 dx is equal to dt. So the quotient becomes 1 upon under root t respect to dt. How to integrate 1 upon square root of t? Square root of t means that is t raised to power minus 1 by 2 dt. And that is further equal to integration of t raised to minus 1 by 2, that is t raised to power 1 by 2 upon 1 by 2 plus c. Now 1 by 2 can be written as 2 times. So the answer would be, final answer would be 2 times, instead of t just replace the value, that is 2x square plus x minus 3 under the root. This 2 goes here, and for t I am putting 2x square plus x minus 3 under the root plus c. So this is our answer for question number 16 of exercise 7.4. Now next we move to the question number, important question, that is question number, our you can say 24. Question number 24 of exercise 7.4. Now question number 24 of exercise 7.4. That is integration of, write it down, integration of 1 upon x square 2x plus 2 respect to dx. X square plus 2x or plus 2 respect to dx. Now this is a question what we have obtained. It is similar to question number 10. 24th question is similar to question number 10, only with the difference. In the question number 10 we have got a square root in the denominator, but here it is without a square root. So now again let us make it a perfect square. For making it a perfect square, what should I do? That is 1 upon, I told you what I was supposed to do, x squared 2x. Look at the coefficient of the x, and that is 2. Make it half of it. Half of the 2 is 1. Make it square. And also subtract the square of 1 from the 2. Yani what we have done, I am taking half of the coefficient of x. Coefficient of x is 2. Make it half, 1. Add up 1 square and subtract 1 square. Or this 2 as it is. Now what we obtain, these three terms always would become the perfect square. If we take up the square of the half of the coefficient of x, this would be x plus 1 ka square. And 2 minus 1 ka square, we get 1 ka square and dx. So this coincides our formula, that is our tangent inverse, formula third, which I told you earlier in the beginning of this exercise, and that is 1 by a. 1 by a is here 1, so tan inverse x by a. Tan inverse x upon a is 1 plus c. So this is the answer we are getting here. Or it was objective type, and the answer is, which answer must be correct? The B one. In the MCQ mein, the correct answer comes to be the B one is the correct answer of this MCQ. Now you see, so this is how we are able to solve the exercise 7.4. So just first of all, what are you supposed to do? Go through the 6 formulae which I told you before the exercise, and then start doing the exercise. In every question, what are you supposed to do? हम क्या करेंगे कि जो denominator है, whether it is with root or without root, we will make it a perfect square. We will make it a perfect square of a 2 terms. So one of the perfect square might be having the variable and the other would be a constant. And then after making the perfect squares, we will look at our 6 formulae, to which formula just what is called coincides with our perfect square, and we'll apply that and we'll get the answer. Thank you very much.